Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. 1. 2-dimethyl-propyl-petoluene sulfonate. The 1,2-dimethylpropyl group refers to a 3-carbon chain with methyl groups at C1 and C2 making the carbon bearing the leaving group, OTS, a tertiary carbon. C1 has 2 methyls and is connected to an isopropyl-like framework. Actually, 1,2-dimethylpropyl means the carbon attached to OTS has 1 methyl, 1 H attached to C2 which itself has 1 methyl and connects further. This is a secondary substrate. Re-examining 1,2-dimethylpropyl is equal to CH3CH, CH3, CH, CH3, weight. 1,2-dimethylpropyl-petoluene sulfonate. The propyl backbone is C1, C2, C3, with methyl at C1 and C2. So C1 bears OTS, CH3, H, and CH, CH3. CH3 group making it a tertiary carbon. C1 has OTS, 1 methyl, connected to C2 which has a methyl. Actually C1, OTS, CH3, H, C2 is equal to secondary. But with a secondary tertiary substrate and acetic acid, apolar, nucleophilic solvent of moderate nucleophilicity, at 75 degrees Celsius, elevated temperature favors ionization. The conditions strongly favor unimolecular mechanisms. Moving on to the next step. Acetic acid is a polar protic solvent with weak nucleophilicity. Polar protic solvents stabilize carbocations through solvation, strongly favoring SN1E1 pathways. The substrate is a secondary or tertiary after rearrangement, alkyl tosylate. The elevated temperature, 75 degrees Celsius, further promotes ionization. Moving on to the next step. Under these conditions, the rate-determining step is ionization of the C-OTS bond to form a carbocation intermediate, unimolecular. This carbocation can then, A, be captured by the solvent, acetic acid acting as nucleophile, substitution via SN1, or B, lose a proton to a base elimination via E1. Both SN1 and E1 share the same carbocation intermediate. And for the final step, SN2 requires a strong nucleophile and backside attack, which is disfavored in polar protic solvents with weak nucleophiles like acetic acid. E2 requires a strong base and is bimolecular, also disfavored here. Both substitution, SN1, and elimination, E1, products arise from the same carbocation intermediate through unimolecular mechanisms. Therefore, the correct answer is D. Therefore, the correct answer is option D.